the very bottom one of it, when we said estimate when our car will have a value of $9,600 based on the fact that it was $31,000 to begin with and decreasing at a rate of about 8% per year. And we had no good way of doing this other than to plug numbers in and happen to get lucky and see if it's 11 years or 10 years or 12 years or 13 years. Okay? Yeah, this is a pain. Okay? And so we won't be able to solve this problem yet today, but we're going to set the foundation so we'll have the tools in order to be able to solve a problem like that. Does that make sense? So if you're doing projections and you want to say, when is this city going to be 1.2 million people based on the annual growth rate right now, you don't want to have to keep plugging numbers in to figure that out. And so that's what's we'll have a method for doing that. So the definition of a logarithm is a log with a base. Little subscript is our base. We usually call that base b. And the log base b of a number, like y, is going to be x if and only if that base to the x power is y. Okay? That's our definition of a logarithm. Log base b of y equals x if and only if b to the x equals y. Now that looks completely foreign. Okay? But we're going to work it out by saying base b to what power gives us y? Okay? Base b to what power gives us the number that's beside it? Okay, so kind of remember that in your head. So, first examples. What's our base in that particular example? 4. Okay, so base 4 to what power is 16? So 4 to what power gets us 16? 4 to the 4th? 4 to the 2nd? What do you think? 4 times 4 is 16, so it would be to the 2nd power. Okay, so log base 4, 4 to what power gets me 16? My answer is 2. Okay, so write that down. Because 4 squared is 16. Okay, next one. Which is the base on that log? 2. Okay, so we have a log base 2 of 8. That says base 2 to what power gets me 8? Okay, so 2 times 2 is 4 times 2 is 8. So what power did we need? 3rd power. Because 2 to the third is 8. Okay? Next one. What's my base? 12. So base 12 to what power gets me 144? 2. Because 12 squared is 144. Okay. Next one. Base 8 to what power is 64? 2. Because 8 to the 2nd power, 8 squared, is 64. Getting the hang of it? Okay. Next one. Log base 2 of 32. 2 to base 2 to what power gives me 32? 5. I start picking on people. Brenna, log base 3 of 27. Base 3 to what power gets me 27? I didn't hear you. 3 to the third power. Good. 3 to the third power gets me 27. Okay. Let's pick on Dawson. Log base 6 of 36 is what? 2. Because 6 squared is 36. Tyler, log base 4 of 1. Log base 4 of 1. Sorry, guys. It would be not 1, 0. Good.
You're doing algebra where it's n to the like the nth power of a.
Mm-hmm.
I don't know if you guys remember this, the nth power of a. So the 4, the log 4, when they're telling you what that the number 4, what do we have to put it to what power to get this? 2 to what power gives us this? 12 to what power gives us this? 8 to what power gives us this? So 8 to the second power gives you this. 12 to the second power, 2 to the third. Okay, that you guys see that? That's where she's getting those numbers.
Okay. So we're saying 4 to what power gets me 1? And it's 0. Okay, because anything to the 0 power is 1. Okay. Log base 3 of 81. Ben. 4. Why is it 4? 3 to the 4th is 81, right? 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay. Log base 7 of 49, Christian. Very good. Because 7 squared gets you 49. So we're looking for the exponent here. Okay. Next one. Log base 4 of 64, Sarah. Very good. 4 to the 4th is 64. So 4 is our answer. We're looking for the exponent. Okay. Log base 5 of 125, Kayla. Oh, sorry about that. 4 times 4 is 16. 16 times 4 is 3. Asleep at the wheel here. Okay. Log base 5 of 125. Very good. 5 times 5 is 25. Times 5 more is 125. Okay. Challenge problem. Who wants to try this one? Log base 3 of 127th.
27. What was it when it was 27 on the other column? So how would I turn it into a fraction with an exponent? Do you? What did we teach you in algebra 1 about can't have what kind of exponent? Negative. You have to flip it, right? Reciprocal. So think that if I gave it a negative exponent, would it flip it then? So what do we write?
Negative 3.
3 to the negative 3 then would give us the 127.
Okay. And last one. Log base 2 of 1/4. Negative 2. Because 2 to the negative second power makes that 2 squared go to the basement. Okay. Feeling pretty good about this? Thumbs up, thumbs sideways, thumbs down. Okay, not too bad. Good. Okay, So now we've spent some time talking about logarithmic form, right? Let's see if we can write these in exponential form then. Okay. If log base 6 equals, oh, log base 6, I missed something here. Should be a 4, right? I believe. Okay. What is 6 to the 4th? 6 to the 3rd, thank you, 36. Yes, 36 should be 3rd. There should be a 3 here. That's what happens when I'm working on lesson plans at 10 o'clock at night. Okay, so how is that, what's that going to say in exponential form? What's my base? 6. So you start with your base, okay? And this is wrong. Should say log base 6 of 216 equals 3. Mark that off on your notes. Change it for me. Yeah. Tried to copy it from my book and it didn't do the exponents right and I didn't check and pay attention. Okay, so what's that going to say? 6 to the 3rd equals 216, right? Okay, 6 to what power gets me 216? 6 to the 3rd equals 216. Okay, the next one actually works. All right, so what should that one say? 7 to the 0 equals 1, right? Because we're saying the base 7 to what power gets me this number? Anything to the 0 power is going to get us 1, isn't it? Okay. Tristan, what's this one going to say in exponential form? 21 to the 1st equals 21. Okay. And Jamie, what's this one going to say? Very good. 1/5 to the negative 1 power equals 5. Okay. All right. Now we have to be able to go the other way. Now we've got our good old exponents that we're familiar with and comfortable and confident with, and we have to take them back to logarithmic form. So Sydney, what's this one going to say? Yep, log base 9, because that's our base. Is it the 2 that goes here and the 81 that goes on the outside? (81) 2. Log base 9 of 81 equals 2. Because base 9 to what power gets me 81? Okay. Manny, what's this one going to say in logarithmic form? Log base, what's your base? 20. Okay. Of 0.05 is the negative 1. The power is always your answer. Okay? Your power is always going to be the answer side of things. Okay? Viv, what's this one going to say in logarithmic form? Very nice. Because 16 to the answer equals the guy that is snugged up next to him. Okay? Make sense? Okay. Joseph, what do you think about this one? What's this one going to say in logarithmic form? Log base what? What's your base? Nope. 15. Log base 15. And then what? 1 over 125, or 225, equals -2. The power is always your answer. Okay? Feeling okay about these? Okay? Nothing too earth-shattering here. It's just something we've not seen before. Okay? So, common logs and natural logs. There are two types of logs. Okay? We were just working with lots of random logs. Had lots of different bases, didn't they? Okay? Now we're going to talk about two special logs. Logs that are actually residing, have tables residing in your calculator. Okay? Back in the days in the 70s, when there were no calculators, there was a whole appendix in the back of Algebra 2 books with lists of logs, tables of logs, and tables of sines, cosine, and tangent angles. Okay, and the decimals that they were to at least 4 decimal places. Okay, they now store all those in a calculator. Okay, so when we want the common log, that's the log base 10 because our number system is based on 10. And when we see the natural log, that's the log base e. Okay, that's that guy that we learned about this couple days ago. 2.71 and so forth, right? Okay, so the common log is the log base 10. We write it as log base 10, or if there's no base and it just says log, then you know it's log base 10. And it's on your calculator, it looks like this. Okay. Then we have the natural log. The natural log is log base e. And again, we get lazy sometimes. We don't write log base e. Instead, we call it ln for natural log. And it looks like that on your calculator. Okay, so everybody found their log buttons? Everybody need a calculator to go find the log buttons? And go grab one and deposit your phone or your keys? And how do we work them? We're going to do that right now, okay? So let's practice this and see what we get. So now we want to find the log of 21. So when you see plain old log, what log are we talking about? Okay, so what you're going to want to do when you want the log of 21, instead of saying 21 log 21, you're going to have to hit 21 log. And that's right. Because right. And that's what's going, okay, so what we do is when we have powers that aren't nice, neat whole numbers, okay, log base 6 of 36 was plain old 2 because 6 to the second power gets me 36, okay? But there's lots more numbers out there than those restricted numbers that have to be perfect powers of the numbers that we're talking about, of the bases that we're talking about, okay? Sometimes we end up with crazy powers, okay? And this is just a screenshot. This is not the screenshot with the right number here, okay? I just took an image from Google and said I want to show them where those buttons are in the calculator. So when we take the log of 21, what do you get? 1.3, we went 3 decimal places, so 1.322. Okay, That means that if the log of 21 equals that, that means that 10 to the 1.322 power is equal to roughly 21. Okay, so because we were before, good question, perfect question. When we said log 8 and we got a 3, that meant that we were using log base 2 because 2 to the third power is 8. Okay, but when we take log base 10 of 8, we get point what? Okay, but when we do log of 8 on your calculator, you get what? Okay, that means that 10 to almost 1, just slightly under 1, is going to get me 8. Okay, 10 to the first would get me 10, but 10 to something just a little bit under 1 is going to get me something under 10. Okay, 10 to the 0.903 gets me the number 8. Okay, because it's not just a nice, neat, round number. Yep, absolutely. We're going to say evaluate without a calculator, or we'll say evaluate with a calculator to do 3 decimal places. Does that make sense? Okay. And there's times when we want to use these log and natural log buttons. We're developing number sense on the first slides that we were doing. And then there's times when we're not going to have nice, neat, round, whole integers. Real world math doesn't work that way. And so we'll have to use our log base 10 and our natural log buttons in order to solve those problems. Okay? So did everybody get 1.322? You know how to plug it into your calculator? Okay? How about this one? The natural log of 0.54. 0.616. Did everybody get negative 0.616 to 3 decimal places? Okay. That means that E, that number that's about 2.7182, whatever, so 2.72, okay, is to the negative 6.16 power, or 0.616 power, is about equal to 0.54. Okay, a number close to 3 raised to a negative power is going to get us a decimal. Yes. Confused on how we got this? Okay. Okay, so you may need to put your, let's see here, we're finding 0.154. You may need to put 0.54 into your calculator first, and then press the LN button. Okay, so then hit clear, and then we're going to do LN of 0.54. Did you get 0.616, negative 0.616? I'll come look at it, okay? It might be in a different mode. So, but that's the whole purpose. That's why we do these problems, is to make sure that you know how your calculator works. Some of them allow you to plug the number in first and then take the natural log. Some of them expect you to put the natural log in first and then plug the number in. Okay? So if you're having trouble, flag us down and we'll help you figure out how to get those calculator values to work. We'll show you the steps. Okay, the 2.71 is the number E. Okay, that's our little E guy that we've been talking about for a couple days. So it's always that. Yep, it's like pi. Pi is always 3.14. E is always about 2.71. Okay, and you can find out what E is by plugging in E to the first on your calculator if you forget what it stands for. 2.718281. So I should really call it 2.72 when I round it. Okay. All right, so we're going to plug these things into the calculator, make sure we know how to work those problems. Okay. So on the log button, when we had the log of 21, we want to make sure that we're using our log button. And on these calculators, on the TIs that we have in the class set, it's just plain old log and 21. They also work for natural log. Okay, but yes, you're right. Once we want to do change of base, we'll teach them that tomorrow or coming up after break. Okay. So we only have two logs that actually are stored in our calculator. We don't have log base 6, we don't have log base 2, we don't have log base 27. Okay, we have log base 10 and log base E, natural log. Okay, all right. So assignment today is the rest of that sheet. There's only something like 12 problems on there, 16 problems. It won't take you all hour. Okay. And you've got examples up above, just like them. Look for the directions to match, and you'll know which ones we did.